Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to continue going over real life stoichiometry problems. I was in the middle of problem 3, so let's continue with that. So in problem 3 we have these hydrogen powered bicycles, and in this problem again we've got the reaction that's taking place in the battery to produce your hydrogen, and they're asking if you start with 1 kilogram of the sodium silicide and your tank has 500 milliliters of water, will you have enough water to use up the battery? So will we have enough water to react? Will this amount of water be enough to react with this amount of the sodium silicide, which is really what the question is asking. So what do we do? So we want to start with the 1 kilogram of sodium silicide and see if all of this will react with all of the water. So do we have enough water to react with this? So if we convert 1 kilogram of the sodium silicide into the amount of water that will react with that amount of sodium silicide, then we can compare that amount of water to the amount of water we're given. If the amount of water we calculate that we need for 1 kilogram of sodium silicide is less than the amount of water we're given, then we have enough water. If the amount of water that we need to react with the 1 kilogram of sodium silicide is greater than the amount of water given, then we don't have enough water. So we need to start with the amount of sodium silicide. So we're going to start with 1 kilogram of the NaN3, and then we want to convert that to the amount of water. And we want to convert that to milliliters of water, since they gave us milliliters of water in our tank. Okay, so we need to convert kilograms of sodium NaN3, and we need to convert that to milliliters of water. So as I was saying before, here we have our main highway, mass of A in grams converting to moles of A. So between that conversion using the molar mass of A, and then we have moles of A converted to moles of B. So we can convert between moles of A, moles of B using the mole ratio of A to B in our balanced equation. And then we have moles of A or moles of B to mass of B using the molar mass of B. So, so we're going to have to start with kilograms of the NaSi. Oh, sorry, wrong thing. That should be NaSi, not NaNZ or N3. So we need to begin with kilograms first. So we need to make that kilograms to grams conversion first using metric conversion. So here I'm going to use this metric conversion. And notice that we want to get to milliliters of water, but here we end with mass of water. So we're going to have to convert grams of water to mass, and there we're going to need to use the density of water. So the density of water is one gram per milliliter. So we have 1 gram per milliliter. So again, that's going to be a good thing to memorize, is the density of water. Pretty much the only density you're going to need to memorize probably. So here is the density of water. So we're going to have to use the density of water to convert from grams to milliliters. So volume in milliliters of B. So using density here. So let's go ahead and get started. So we got 1 kilogram of the sodium silicide, NaSi. That's going to be over 1. And our first step is to convert kilograms to grams. So we're going to use this relationship here. Since I have kilograms on the top here, I'm going to have kilograms on the bottom. So 1 kilogram goes on the bottom. So I have 1 kilogram of the sodium silicide on the bottom and 1,000 grams on top. So that's 1,000 grams of NaSi. And so now I have grams of the NaSi. So now I'm here on my roadmap. So the next step is to go from mass in grams to moles. And I'm going to use the molar mass of the NaSi. So the molar mass of NaSi is going to be 51.08. So that's going to be 51.08 grams. So 51.08 grams of the NaSi is equal to 1 mole of the NaSi. So that's what I'm going to use. So that's my next conversion. So since I have grams of NaSi on the top here, I'm going to need grams of NaSi on the bottom. So 51.08 grams goes on the bottom. So 51.08 grams of NaSi goes on the bottom. And then 1 mole of NaSi goes on top. So grams of NaSi cancel out. Now I have moles. Now I'm here. So the next step is to go from moles of A to moles of B using the mole ratio. So my A here is sodium silicide, and I want to get to water. So that is here. I'm going to use the mole ratio, 2 moles of NaSi to 5 moles of water. So I'm going to use that. So since I have moles of NaSi on the top here, I'm going to put moles of NaSi on the bottom. So I'm going to need 2 moles of NaSi. So 2 moles of NaSi on the bottom and 5 moles of water on top. So 5 moles of water on top. So moles of NaSi cancel out. Now I have moles of water, which is my B. So now I am here on my roadmap. So 2 more steps. So moles of B to mass of B in grams, and then grams to milliliters. So I'm going to use the molar mass of B, which is water, to convert moles of water to mass of water. And that is 18.02. So 18.02 grams of water is equal to 1 mole of water. So that is the molar mass. So I'm going to use that to convert moles to grams. So since I have moles of water on top, I need moles of water on the bottom. So 1 mole of water. And then 18.02 grams of water on top. So 18.02 grams of water on top. So moles of water cancel out. Now I have grams of water. So now I'm here on the roadmap. I have one more leg of my trip. So I need to use density of water. And so here I have the density of water is 1.0 grams per 1 milliliter. So it's 1 to 1. So since I have grams of water on the bottom, I'm going to put 1.0 grams of water on top and 1 milliliter of water on the, 1 gram of water on the bottom and 1 milliliter on top. So grams of water cancels out. And now I have milliliters of water, which is what we want. So we're done. So now all you need to do is multiply by everything on the top. So on your calculator, so 1 kilogram times 1,000 times 1 times 5 times 18.02 times 1, and then divide by everything on the bottom. Divided by 1, divided by 1, divided by 5.08, divided by 2, divided by 1, divided by 1. And then you'll get your answer. And the answer is 881.95 milliliters of water. So this is the amount of water needed to react with 1 kilogram of your NaSi. How much water do I have in my tank? I only have 500 milliliters. So I do not have enough water in my tank to completely react with all of the NaSi in my battery. And so that's how you work this problem. So again, if you enjoyed this video, if this is helpful in helping you do stoichiometry problems, especially on real life type situations, then please like my video, hit that like button right there, subscribe to my channel, hit that notification bell right up there so you can be notified by other videos I put out. Share my videos, share my channel with other people. Put a comment down in the comment section. Let me know what you think. And if you've got any questions, let me know. Thanks for joining me. Have a great day.